Welcome to my personal crew quarters on board the International Space Station. This is where I sleep, this is where I send emails from, talk to my family, this is where I have some personal space. But it's also where I'm testing one of the technologies of my Huygens mission, more specifically a circadian light panel. One of the challenges that we have when we live on board the International Space Station is that there's no natural day-night cycle. There's no natural time zone for us. We choose to work off of Greenwich Mean Time, but in fact we could have chosen any time zone in the world. And that's because we orbit with a velocity of about 28,000 kilometers an hour, which means it takes us only an hour and a half to circumnavigate the Earth once. Or in other words, in the space of 24 hours, we see 16 sunrises and 16 sunsets. All that to say that there is no natural time zone up here. And as a result, our bodies lose their connection to the normal day-night rhythm of life on Earth. And in fact, our body's natural rhythm is slightly longer than 24 hours. But on Earth, the natural rhythm of the body is regulated to 24 hours by the sun's light. When the sun rises and when it sets, there's a natural fluctuation in the brightness, but also in the color of the sun's light. And that helps to signal to the body when it's time to get up and when it's time to go to bed. And since we don't have that up here, we don't wake up as easily on board the space station, and we don't get that natural tiredness or sleepiness at night when it's time to go to bed. SAGA Space Architects, a company in Denmark, has developed a light panel which attempts to mimic the changing color of the sun's light during a 24-hour period. Right now it's the middle of the day, and so the light panel is emitting white light. But I can put it on a demonstration cycle that'll imitate the 24 hours in just a couple minutes to demonstrate the changing or the fluctuation in the color of the light. So obviously, when it's night, the light panel is off, it's dark, and I'm sleeping. But as we approach the morning, say 5 a.m., 6 a.m., the light panel will automatically turn on, but very, very softly and in a reddish glow. And that mimics the natural sunrise on Earth. And as you can see, it's starting to come now. It quickly switches over to bright white light, again mimicking the rising sun. And this is the color of the light for most of the day. And then towards the evening, it'll again shift to a different wavelength and begin to dim itself automatically, again simulating the setting sun. The idea is that a light panel like this can help regulate our day-night cycle, our circadian rhythm on board the International Space Station, which will make us sleep better. And through the better sleep, it'll make us more energetic during the day. It'll increase our cognitive abilities, our abilities to concentrate, our reaction times will improve. In general, our mental state will be vastly improved through better sleep cycles and through a better overall circadian rhythm. And as you can see, we're now approaching night. It's turning more yellowish, slightly reddish, and dimming by itself until it gets to about 10 p.m., in which case the light will completely extinguish and it'll be time for me to go to bed again. Very interesting technology that can vastly improve the life of astronauts on board the International Space Station and on future deep space missions.